So
this call is now.
okay, so you may take notes on this if you wish. So we're going to look at a few different types that can come up. They're no more different than anything you've probably come across before, maybe last year, but we'll just go over them again. All right. Let's start with, we'll do a two-step just to start off with, although it's not necessarily two steps. So this is the last two-step I'll give you an example of. After two-step, they're called multi-step because it could be 3, 4, 5, 6 steps, but we just call them multi-step. We don't name them. But okay, so let's do one more. So let's take 1, 5 plus x over 2, and we want to find out what's the answer for that if it equals 7. We want a method. Now in the exam, you might be able to work this one out in your head and figure out, well, 5 plus something divided by 2 is 7, so it has to be, well, 4 divided by 2, as Harry says, yeah. But just writing x equal to 4 in the exam will not cut it because we're learning a method. We're trying to understand all the concepts behind solving and not just getting the answer, because getting the answer is, relatively straightforward for 1 and 2 step equations. But unless we have the same method, as I say many times, when it comes to these multi-step equations, which we'll be doing in a minute, if we don't have a method, it's impossible to guess. Well, it's not impossible, but what happens if it's an awkward fraction or a non-reoccurring decimal, so like an irrational number? What happens if the answer is irrational? You cannot guess that. So a decimal like 0.73476625, decimal like that would be not something you could guess or figure out just by looking at a question. Okay, so let's once again revisit the methods. So it's a balance method, so you do the opposite thing to both sides of the equation, so opposite and balance. All right, so I want x isolated. This x, I want it on its own. The 5 and 2 gotta go. So I'm going to subtract 5 from both sides. Because that 5 has nothing got to do with this 2, I can do that. If the whole thing was divided by 2, then I would probably multiply both sides by 2 first, because the 5 would be over the 2. But if the 5 is just on its own here, I can subtract. Remember, if it has no sign, it's automatically positive. So this is positive 5, and that is positive 7. I add or subtract going down. 5 take away 5 is nothing. X over 2, equal sign underneath. 7 take away 5 is 2. Now that's one step. Second step, if I want to get rid of a dividing by 2, I would balance the equation by multiplying both sides by 2. The opposite thing to dividing by 2. That will cancel out. Yeah, we know it's 4. We already got that far. Okay, so x is equal to 4. So that's an example, our final example of a two-step. Okay, so now we are going to look at what happens if we get some brackets. And this is our first of our multi-step type equations. So if we have 5 times 2x plus 3 is equal to negative 20. Okay, that's our question. So this is our first multi-step. There's 2 methods I could do for this. I could start by dividing, so that, first of all, there's 3 numbers to get rid of. 1, 2, 3. Now that's already telling me that there's a multi-step, because x here has got to be on its own. If there's 3 things to get rid of, that already goes beyond 2 steps. So I could divide both sides by 5 to start, but I'm going to multiply and get rid of the brackets first, using the distributive rule. So we did this earlier on, the distributive rule. In other words, multiply 5 by both these. 5 times 2x gives 10x. 5 times 3 gives 15. And that equals still negative 20. So remember, if a number is outside the bracket, it's got to be multiplied by both terms. Now it's a 2-step. Why is it a 2-step? Because there's 2 numbers, 15 and 10, to get rid of. So I subtract 15 and balance the equation. You notice the way I didn't solve anything here, and yet I still got rid of one of the numbers. I didn't quite do the balance method here. So for brackets, you need to remove them first. Just remove brackets. So I'd always remove brackets first. Okay, so 15, take away 15, that's the one that cancels out. I have 10x, okay, I'm here. equals minus 20, take away 15. So that's negative 20, take away another 15, that's negative 35. Divide both sides by 10 now, because that's 10 times x. Divide both sides by 10. And x is, well, you could go minus 3.5 is acceptable, or you could simplify that fraction if you wish. It can be minus 7 over 2, wouldn't it? Okay. So here's an example of maybe we couldn't have guessed that straight away because we're getting into negative numbers and decimals. And that's what's going to happen with these multi-step. So with the brackets, remove the brackets first. What happens if we have more than one bracket? So we're left with something like 3x minus 2 minus 2 times x minus 7 equals 12. Okay, I can't guess this one really, but I definitely can multiply out the brackets first. This, how many numbers do I need to get rid of? Well, I'm all 1, 2, 3, 4 different numbers, and there so happens to be 2 x's. There's an x here and an x there. Let's see what happens. So if there's more than one x in a problem, we must simplify it at some stage to get it down to 1x before I start solving. All right, so let's first of all get rid of the brackets. Distributive rule. 3 times x, 3x. 3 times negative 2, negative 6. All right, now I need to multiply by negative 2, both these things. Remember, negative 2. Negative 2 times 3, or times x, negative 2x. Negative 2 times negative 7. Negative times negative is a plus. 7 times 2 is 14, equals 12. Now at this stage, I have an issue. I have two x's on this side of the equation. What do I do to get rid? I simplify. So we did simplifying as well this unit. You add any like terms before I start solving. So I haven't started solving yet, and even when I simplify, it's not term solving until I actually start removing stuff like this. All right, so 3x take away 2x leaves me with 1x. Negative 6 add 14. Well, that's 14 take away 6. So it'd be plus 8. And that equals 12. And here we are with our one-step equation. Now I solve. Now I can do the balance and subtracting. And x is 4. Okay, so that's the types of questions involving brackets. Now let's do a question where the x's are not on the same side of the equals, but on different sides. I'm just going to call this section x's both sides. Oh, not both sides, but anyway. X's both sides. So we have something like this. I'm going to solve this. And once again, guessing here is going to take a while. 2 times some number adding 7 is the same as negative 5 times some number plus 3. So having a guessing game here would take a while. I'm just coming up with the answers. So this is where our method will never leave us down. It'll be our friend. Okay. I would usually get rid of the smallest x value first. So there's negative 5x's here, and there's positive 2x's there. Which is bigger? Well, positive 2x is bigger. So I'll keep that. And I'll get rid of negative 5x. When I say get rid of it, how do I get rid of something in this algebra? Well, I do the opposite thing. So that's subtracting 5x. So if I've added 5x here, that will cancel out. And I add 5x there to balance the equation. If you do something to one side, you must do it to the other side. Draw my line. That disappears because 5x take away 5x's. It's gone. Now, 2x plus 5x gives me 7x. Sorry. Plus 7 still here. And that equals, well, there's only plus 3 here, so I'm just going to write 3. Remember, I don't need to write the sign if it's positive, and it's only itself on that side. All right, now it's just a 2-step to finish. two numbers, 7 and 7 to get rid of. Get rid of this 7, subtracting 7. So I'm left with 7x is equal to 3 minus 7. So that goes into the negatives, negative 4. Dividing both sides by 7 to get rid of 7 times x. And x is, well, that's an example of an awkward fraction. It's just negative 4/7. I wouldn't have guessed that at the start. It would have taken me quite a while to guess that number. So that's why our method is key. All right. I'm going to do one more. And it's going to be as hard as they get. No, I'm not muted. I'm not talking. One last one. If you guys want to have a go at this and try and get it done before me, do type your answer in the chat. I think it's going to be quite difficult to guess this answer as well. That's an understatement. There's now 3 x's. There's x's on both sides. There's brackets and there's fractions. The trio of disaster for solving equations, or the trio of triumph, if you know what to do. Well, first things first, I think it's a good idea to get rid of these brackets. And then I won't have any more brackets. So multiply in. Minus 2 times x gives minus 2x. Minus 2 times 5 gives minus 10. And that's all still divided by 5. I'm going to deal with that afterwards. I'm now going to multiply plus 7 by these two. Remember, it's called the distributive rule. Multiply by both. Plus 7x. 7 times x, and then 7 times 3, 21, plus times minus, minus, so it's minus 21, equals 2 times x, 2x, 2 times negative 7, negative 14. All right, it's already looking a little bit better. It's still not great, because I have this division by 5. If that wasn't there, this would be a lot easier. So what I'm going to do is I'm going to multiply both sides by 5 to get rid of that. So multiply this whole side by 5 and this whole side by 5. Remember, I balanced the equation. Now, if I multiply this and this by 5 and then divide by 5, that will cancel out, won't it? Now, the problem is this isn't divided by 5, so I still need to multiply this by 5 and this by 5. And this by 5 and this by 5 on the other side, because they're all both sides are multiplied by 5. Okay. So minus 2x minus 10. Well, the dividing and multiplying by 5 cancel each other out. 7 times 5 is 35, so that's plus 35x. 5 times 21 minus, because it's minus, 105, I think. 5 times 2x, 10x. 5 times 14 then, well, 5 times 10, 50. 5 times 4, 20. So put them together, 70. All right, no more fractions. Maybe, Reese, maybe. Okay, I have like terms, so I can simplify. So I just can combine, anytime I combine like terms, that's simplification. 35 x's take away 2 x's. Well, that's going to be 33x. 35 take away 2. Minus 105 take away another 10. Well, that's minus 115. And that's still equal to 10x minus 70. Okay, now we're getting somewhere. Now I need to get rid of the smaller x. Which one's smaller? This one. Take it away. It's already positive, so I minus. Both sides. I've started to solve. I've expanded brackets using the distributive rule. Bit of solving here because I'm multiplying to cancel out that 5. And then I simplified. And now I'm back to solve. That's gone. 23x, oh Reese, you might be right, minus 115 equals negative 70. add 115 to both sides to get rid of 115 negative here. Cancels out. 23x's is, well, 115 take away 70. Going to be 45. Final answer then, divide both sides by 23. And we've x is equal to positive 45 over 23. Well done, Reese. You wouldn't have guessed that, though, when we started. When you looked at this problem, you're not thinking of 45 over 23 as an answer. It doesn't even cross our minds. So you'd never be able to, well, maybe you could, but you're not be able to do this without a method. Method is key. Okay.